Hi, in this video we're going to talk about surds. 1, 4, 9, 16. These are square numbers. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and 16 is 4 squared. Now, if you take the square root of these numbers, you always end up with an integer, because you take the square root of these index numbers, and what happens is the square root and the square cancels each other out, and then you get, as a result, let's write with this, 1, 2, 3 and 4. So you always get an integer because these numbers are square numbers, right? So when you don't have square numbers inside square roots, like let's say square root of 3 or square root of 5, square root of 8, square root of 24, these are called as surds, meaning they are irrational numbers, because what you get is a decimal which goes up to infinity without repeating itself, like pi, right? So these are called as surds, and basically surds are irrational numbers, which means you cannot write any of these as a fraction. These are just irrational numbers. So within our scope, we will either simplify surds or we are going to expand and simplify. Let me show you an example. Now, the idea behind simplifying these surds is to write them as a product of a square number and whatever else is remaining, right? And in this one, root 12 is square root of 4 times 3, and square root of 18 is 9 times 2. Now, next we are going to use these rules. Basically, these rules are the extension of index rules. Remember, we were to have a to the power of n times b to the power of n, which could be written as a times b to the power of n, and this works both ways, right? You can just convert this to this, or vice versa. So if you consider these surds as, let's write here, a to the power of 1 over 2 times b to the power of 1 over 2, then this could be written as a times b to the power of 1 over 2. With 1 over 2, we mean the square root, so it's the same thing. So we are not learning anything new, we are just extending this index rule to surds. Now, as I said before, we need a square number inside the square root, because that's how I'm going to simplify these numbers. For square root of 8, I have square root of 4 times 2, which would be square root of 4 times square root of 2, and then I can just take the square root of 4 and write 2. So that's going to be 2 times root 2. And that's going to be square root of 4 times square root of 3, and it's going to be 2 root 3. And now I can skip this step actually and directly write down 3 root 2, knowing that I can take the square root of 9 and take it outside the square root and write it as a simple 3 root 2. Now in these examples, we're going to just expand, right? So it's going to be 3 times 5, which is 15, minus 3 times root 3. Now please be careful, you cannot multiply integers and surds, so you write the product like 3 root 3. Please make sure that you don't write 9, right, or square root of 9. These are not correct. 3 and root 3, you cannot multiply these numbers, you just write the product as 3 times root 3. Okay? Next, it's 2 times 1, 2, 2 times, now, here we have 2 root 2, 3 root 2. So I can multiply integers by integers. So I will multiply 2 and 3, ending up with 6. So it's going to be 6 root 2. So consider those surds as apples. 2 times 3 is 6. So it's 6 apples, 6 root 2. So it's just there. You cannot make any operations with them. So here, root 7 times 3, again, it is not root 21, it's not 21, it's just 3 root 7 minus root 7 times root 5. Now I can do this operation because both expressions are surds, right? 7 times 5 is 35, so this will be root 35. Remember the rule. You will have root 7 times root 5, which you could write as root 7 times 5. That's root 35. But you don't need to show these steps. You can directly write the product. Now in this example, we again multiply with root 3. And what I'm going to get is, this is root 3 times root 12, root 36. Plus root 3 times root 4 is root 12. Now I can't stop here. I have to simplify this expression. So root 36 is basically 6, because 36 is a square number, right? And root 12, now you can consider this as root 4 times 3 and write 2 root 3. So this goes here, right? So basically you're going to have, let me just clean it up here and write properly. It's going to be 6 plus 2 root 3, right? So yeah, it's not only expansion. Sometimes you can feel the need to simplify it further, because you will see in questions that they will ask you the exact or simplest value or answer. So this is how you should deal with these and end up with the simplest form. So what happens if we have two terms in brackets? Well, remember from algebra that you have to expand the brackets like this, right? So that's what we're going to do now. 3 times 4 is 12. 3 times minus root 6 is minus 3 root 6. And, well, I'm not going to color code this, but now I'm here with the purple. So it's root 7 times 4. Please keep in mind, I don't write root 7 times 4 like this. Doesn't make sense. The integer always comes first, because remember, we're not using the times symbol, so we have the order of integer and surd. Minus, now root 7 times root 6, 7 times 6 is 42, so I end up with the 42 here. Now, this expression has nothing to simplify, because these two especially, these are the ones that I could simplify, they don't have the same surd. This is root 6, this is root 7, and I cannot add them. Please be careful. This is not a case that you add integers separately, you add surds separate. There's no such thing, okay? This is just 3 root 6 there and 4 root 7 there. We cannot add them. Now, another example. So in this one we have 2 times 3, 6. And then 2 times root 5 is plus 2 root 5. And then I go with this. Root 5 times 3, 3 root 5, but it's minus, right? 3 root 5. And then root 5 times root 5. Well, that's going to be root 25. Yeah? Now if I go on, well, 6 is 6. And I'm going to now do this operation, because this is 2 root 5 minus 3 root 5. This is like 2 apples minus 3 apples. So it's going to be minus 1 apple or minus 1 root 5. Of course, I'm not going to write 1. So so it's going to be minus root 5. And 25 is a square number, so I can just take the square root of 25 and write 5. Now I have further simplification here. 6 minus 5 is 1, so I should end up with a number like this. So this is where you simplify after expanding. If you have the same surds, like these, then you can simplify. So when it comes to addition and subtraction of surds, we must make sure that we have the same surd in each term, otherwise we cannot add or subtract. Here we can, because, well, I will consider these as apples or whatever you like. There are 3 of them here and 7 of them here too, so this makes a total of 10 apples, whatever, and then you have to take 1 away, so it must be 9. So 3 plus 7 minus 1 makes 9, so it's going to be 9 root 5. So these are the easiest. So you won't be able to see such a question in the exam, but you can see this. Root 18 plus root 8 minus, let's say, root 50. Now, each one of these surds look different, but if you simplify them, you're going to end up with, well, that's going to be 9 times 2, that's going to be 4 times 2, and this one will be 25 times 2. Notice that I always find a square number inside the surd, right? 9. I mean, I don't write 18 as 3 times 6, because neither 3 or 6 is square number. It doesn't help. Or 50. I don't write 5 times 10. Neither 5 nor 10 is square number, so I can't take any one of these out. I need a square number in this product. So 9 goes out as 3, so this is 3 root 2. 4 goes out as 2, so this is 2 root 2. And 25 goes out as 5, so this is 5 root 2. And basically 3 plus 2 minus 5 is 0. So that's 0 root 2 if you'd like, but I prefer to write 0. Right, 7 questions, and you will simplify, expand, or expand and simplify. So please solve on your books and submit your answers online. Thank you for watching.